Okay, for this video, we're going to try these now. So this is our try now. It's a solve and graph question. So I'm hoping that when you're doing the question, you can watch the video where you need support. And if not, then you can kind of zoom to the answers just to see that our answers match. Okay, make sure the steps are shown, and we want to see all the beautiful steps, because remember, this year in grade 9 we are working on proper steps so that you can continue these nice habits for future math years. So here, this is just solving, so it works just like an equation. I want all of the x's on one side and the numbers, so any of the terms with x's on one side and the numbers on the other side. Doesn't matter which side, it'll work the same way. So if I say, okay, I can see that there's two terms with x's here, I'm going to move this one over. What do I mean by move over? When it crosses the barrier, it has to switch signs. So these guys are all the same. This is the only one who's moving. If I move all the terms with x's to the right side, I need you to move this one over there because it has no x. So when it hops over my barrier, these are the ones with arrows. So this one has an arrow, this one has an arrow. When it has an arrow, it's going to switch operations. So I put this sign here. The 12 hops over and becomes negative 12. This one leaves, so it's no longer there. The 5x did not move and the 3x did not move. But this one with the arrow, it's hopping over the barrier, so it's going to become minus 2x. Okay. Now I can collect up all my like terms. You get negative 12 is less than 5 plus 3, so 8 minus 2, so it'll be 6x. And then here, you're going to divide both sides by the 6. That cancels it. So whatever's in front of the x, you divide exactly by whatever that is to make it 1. Then you get negative 12 divided by 6, which will be negative 2. Okay, and that's it. It's a straightforward question because you only divided by 6. Some people might say, what if I did it the other way? What if I switched the sides the other way? And that'll work as well. So I'm just going to show you both, and then I'll do the graph. So what if you said I brought the 5x over? So I'll show you. So 2x is less than 5x plus 3x plus 12. Oops, right, this markers. No, I'm going to do it here. So we go 2x, this is 5x, 3x plus 12. So what if you said, you know what, I thought I would move the terms of the variable over, right, to gather them all up. So these guys crossed over the barrier, and I did it this way. And I'm just going to show you it works the same way. So you're going to get 2x stays where it is. It did not move, so stay as is. This one becomes a minus 5x. This one becomes a minus 3x, and it's less than 12. So if I go 2x minus 5x, that'll get me negative 3x. Minus another 3x, that'll get me negative 6x. Then you go, okay, so I have to divide by a negative 6. When you divide by a negative on this very last step, the only time you should be dividing by a negative is on the last step. So the only time that should ever happen is this last step. And then I'm going to do this. So it really only happens on the very, very last step. So then this sign will now change from this direction where the mouth is this way to this direction. So it's going to go and switch because I divided by a negative. So that's the only time this ever happens is the very last step. 12 divided by negative 6 would be negative 2. And you might say, are these the same answer? Read it from the x. X is, see the mouth is open, greater than negative 2. Read it from the x. X is, see the mouth is open to the x, greater than negative 2. So for both of these, you actually got the exact same answer. So either way you bring the variables to the left side or the right side, you should still get the same answer. Okay, remember, the division really is the only time that you're ever going to divide by a negative. Right here, the last step. So that's the only time you'll change the direction. So you're going to do open circle. Oops, this pen is out. So open circle on the negative 2, right? Because it's not equal to it. So open. And see how the mouth is open to the x. X is greater than negative 2. Here, x is greater than negative 2, so to the right. Right? When the mouth is open to the x, it's greater than. Okay, so both ways will work. You should get the same answer mathematically. Let's do B. Okay. So for B, we're going to do this. Again, I want to grab all of the terms with the variable onto one side. So I have this one, A, and the positive 3A. And then, so I might as well bring this one over here, because there's already 2 with A here. And then, and what I mean by bring over, again, right, means crossing the barrier, this one here. You'll notice, one more time, no equals along here. There should be nothing here. So no equals here. So no equals this side. So no equals on this side. You've got your inequality here in the middle that we're trying to line up, but no equals on the left side. It's like a run-on sentence. It's too many equals or equation or inequalities. Okay, so when it crosses the barrier, it gets the arrow. These guys did not move. A did not move, so leave it. 3A did not move, so exactly the same. Negative 5A becomes a positive 5A, or minus 5A becomes a plus 5A. This 7 did not move, so leave it. This is plus 12, which now becomes minus 12. 7 minus 12 is negative 5. I have an invisible 1, right? Remember, it's invisible 1 plus 3. 1 plus 3 is 4. 4 plus 5 is 9. I'm going to divide both sides by 9, so I do not have to change direction. So 1, do not change direction, you're only dividing by 9. So this stays negative 5 over 9 is greater than or equal to A. And that is actually your answer. I'm going to take this. If it's greater than or equal, it's a solid dot. Label it. Solid dot because it's also equal. And see how it's closed? Closed. Negative 5 over 9 is greater than or equal to A, or I read it from the variable. A is less than negative 5 over 9. See how it's closed to the A? Closed to the A. It's heading that way. Closed to the A, which means A is less than or equal. So less than or equal would be left. And we know it's a solid dot because it's equal. The equal means solid, not equal means open. Okay, so not equal is open, equal is solid. One more for this page, and we're going to do some fractions with the solving inequality. So see how the y is in between? The y is kind of in between the 5 and the 6. I would like you to move it up to the top. So I want you to rewrite this, 5y. So it's in between, but it's actually over 1. So that over 1, right, over 1 means it's together with the 5 and the 6. So let's put these guys over 1. So I want you to rewrite that 5y over the 6. Okay, that is a bit of a trick because people go, where does the y go? It actually goes at the top, not the bottom, with the 5. And it's actually over 1. So top times top, bottom times bottom, like that. And then leave the 4 over 1. Okay, does that make sense? So right here, star this. People don't know what to do when the variable's in between. You just put it over 1, so it'll be numerator times numerator, denominator times denominator. So 5y over 6 plus 4. This I'm leaving it the same. But now we have to look at all the denominators. There's a 6, a 1, a 4, and a 3. 6, 1, 4, 3. And then you're going to say, what's the lowest common denominator between 6, 1, 4, 3? Start with the biggest guy. Go 6, no. Double it, 6 times 2, 12. Yes. Okay, and you keep working with the biggest one. So to make it 12, you're going to multiply. So lowest common denominator is 12. Okay, so I'm going to do times 12 on the top and the bottom of this guy. This one needs 3, and this guy here needs 4. So look, they'll all be 12 now. So you go 5y times 2 is 10y over 6 times 2 is 12. 4 times 12 is 48 over 1 times 12 is 12. 3y times 3 gets you 6 y's. 4 times 3 is 12. 1 times 4 is 4. 3 times 4 is 12. And there we go. So once they're all the same, we dump the bottoms, dump the denominators, and rewrite it. Okay, one more time, we want to get all of the terms of the variable on one side, and then all the numbers with no variable on the other side. So I'm going to move this one here. It crosses the barrier, so it gets its arrow, it changes the sign. This one here will cross over as well, so that will also get its own sign. It's a change of sign. So I'm going to go 10y, 6y hops over, right, crosses the barrier, so minus 6y. The 4 stays where it is, but the positive 48 hops over, negative 48. Then it's just 10y minus 6y, so you get 4 y's left. 4 minus 48 is negative 44. How do we get this final answer solved? We want y by itself, so divide by whatever's in front of y. Identical. And then y would be greater than negative 44 divided by 4 is negative 11. I divided by a positive number, so I don't have to change the direction. If it's, see how it's open towards the y? Y is greater than, but not equal to, negative 11. So you do open circle on negative 11, open, and then y, see how the mouth is open towards the y? Y is greater than negative 11. So to the right. Like that. Okay, so you want to follow the steps.